Good afternoon students. Welcome back to online maths class. So in the last class we have solved up to the 21st question. Let us continue with the 22nd question of the exercise 9.3. If the pth, qth and rth terms of a GP are a, b and c respectively, then prove that a to the power q minus r into b to the power r minus p into c to the power p minus q is equals to 1. He is talking about pth term, qth term and rth term. So, I will read the given information. Given pth term, that is AP. So, it is AP which is equals to A, pth term is A, and then qth term, that is AQ, which is equals to B, small b, and then rth term, that is AR, which is equals to C. So, as they have already used small a and small r, that is the first term and the common ratio. That is why to distinguish I am going to use capital A as the first term and capital R as the common ratio. What is AP here? AN is nothing but A into R raised to n minus 1. So, here AP can be written as A into R raised to P minus 1. This becomes A into R raised to P minus 1, which is equals to A. And then AQ can be written as A into R raised to Q minus 1, which is equals to B, and then A into R raised to R minus 1, which is equals to small c. Is that clear? So, here AP, pth term is nothing but A into R raised to P minus 1, qth term is A into R raised to Q minus 1, rth term is A into R raised to R minus 1. I will take the left hand side now. I will take the LHS. After simplifying, we should get the answer as 1. So, LHS, which is equals to A to the power Q minus R into B to the power R minus P into C to the power P minus Q. C to the power P minus Q. So, now left hand side, which is equals to A. What is A here? Small a is nothing but A into R raised to P minus 1. Substitute that now. A into R raised to P minus 1 to the power Q minus R. To the power Q minus R. Then into B to the power R minus P. Small b is nothing but A into R raised to Q minus 1. A into R raised to Q minus 1. A into R raised to Q minus 1 to the power R minus P into C to the power P minus Q. C is nothing but A into R to the power R minus 1 whole to the power P minus Q. P minus Q. Now, this is in the form of AB whole raised to M. AB whole raised to M can be written as A raised to M into B raised to M. So, Q minus R will be applied to the first term as well as to the second term. Left hand side, which is equals to, this is equals to A to the power Q minus R into capital R to the power P minus 1 into Q minus R. Then similarly, here capital A to the power R minus P, then into capital R to the power Q minus 1 into R minus P, then A to the power P minus Q, then into capital R to the power R minus 1 into P minus Q. P minus Q. So, now see here, group only the capital A terms, A raised to Q minus R into A raised to R minus P into A raised to P minus Q can be written as left hand side, which is equals to capital A to the power Q minus R plus R minus P plus P minus Q. P minus Q. A raised to M into A raised to N form ದಾಗ ಅದ್ರಿ ಇದು ಅದಕ್ಕೆ ಈ ಥರ ಬರ್ದಿದ್ದೀವಿ. Then into capital R to the power all these terms. So it is P minus 1 or else multiply P minus 1 with these two terms and similarly Q minus 1 with these two terms and R minus 1 with these two terms and then add up all the terms. So here capital R PQ, the first term it is PQ, P into Q, then P into minus R, it is minus PR, and then minus 1 into Q, it is minus Q, and then minus into minus plus R. We are done with the first case. Now take up this one, multiply both the terms. Q into R it is QR plus QR and then minus PQ and then minus R, minus into minus plus P, and then now take up these two terms. It is PR, RP or PR, both are same, and then minus QR and then minus P, minus into minus plus Q. We will have to simplify this further. Left hand side which is equals to A to the power, see here, here plus Q minus Q get cancels, minus R plus R get cancels, minus P plus P get cancelled, you get A to the power 0. And then into R raised to, here again all the terms get cancels, PQ and then minus PQ, minus PR plus PR, minus Q plus Q, then plus R, then where is minus R? Here it is. Then plus QR minus QR. All the terms get cancels, plus P minus P. So you get R raised to 0. So A to the power 0 value it is 1, R to the power 0 value that is also 1. So overall the answer is going to be 1. This is the required RHS. So this is all about the 22nd problem. Note down this and then we'll move on to the next problem. Well, the 23rd question it is, if the first and nth term of a GP are A and B respectively, and if P is the product of n terms, prove that P square equal to AB whole raised to n. So we'll write the given information and then we'll go for the LHS. So here he says the first term it is A, small a, and nth term it is B. So given, we'll go for the given. First term is equals to small a. First term equal to small a and nth term is small b. And or we know that nth term of a GP, an which is equals to a into r raised to n minus 1. He says here nth term is small b. This implies a into r raised to n minus 1 is equals to small b. R raised to n minus 1 equal to small b because b is the nth term. So and he says p is the product of n terms. So here p equal to p which is equals to product of n terms. So consider the n terms of geometric progression. A into AR into AR square and so on, a into r raised to n minus 1, a into r raised to n minus 1. These are the product of n terms of a GP. So here the terms can be rearranged. ಅಂದರೆ ಇಲ್ಲಿ ಟರ್ಮ್ಸನ್ನು ರಿಅರೇಂಜ್ ಮಾಡ್ಕೊಳ್ಳೋಣ್ರಿ ನಾವು. ಎ ಇಂಟು ಸೋ ಆನ್ ಎ ಅಂತ ಬರಿಬೋದು ರೀ. ಸೊ ಹಿಯರ್ ಎ ಇಂಟು ಎ ಸೋ ಆನ್ ಎ, the last a then into what is the other term? R square, R cube, so on, R raised to n minus 1. So R raised to 1 into R raised to 2 into R raised to 3 into so on R raised to n minus 1, R to the power n minus 1. This is the second term. Then P which is equals to, so here A is repeating n times. A n times repeat agidre. A 2 times repeat agittu andre A square anta baritidvi. A 3 times repeat adre A cube anta baritivri. A n times repeat adaga A to the power n anta baribodri. This can be written as A to the power n. It is A raised to n. Then how do you write the second term? It is R to the power 1 plus 2 plus 3 plus so on plus n minus 1. The powers will be added up. So now in the next step, P which is equals to A to the power n, write it as it is. Then so what is 1 plus 2 plus 3 plus so on n minus 1? So in the 10th standard, in first chapter, that is arithmetic progression, you have studied sum of first n natural numbers. So find the sum of first n natural numbers at one problem itrele itara 1 plus 2 plus 3 plus so on plus n. Adre ee problem solve madidde ನಾವು ಅಂದ್ರೆ ಏನು ಬಂದಿದೆ ಆನ್ಸರ್ n into n plus 1 divided by 2 ಅಂತ ಬಂದಿತ್ರಿ ಸಮ್ ಆಫ್ ಫಸ್ಟ್ n ನ್ಯಾಚುರಲ್ ನಂಬರ್ಸ್. ಸೊ ಇಲ್ಲಿ n ಇದ್ದಾಗ n ಬರ್ತದೆ. ಈಗ ಏನಂತ ನೋಡ್ರಿ ನಮಗೆ ಇಲ್ಲಿ 1 plus 2 plus 3 so on plus n minus 1 ಅದ ರೀ. ಸೊ ಹಿಯರ್ ರೀಪ್ಲೇಸ್ n by n minus 1 n minus 1, then replace n by n minus 1, write plus 1 as it is, then whole divided by 2. So n minus 1 remains as it is, plus 1 minus 1 get cancels, you get n divided by 2. ಅಂದ್ರೆ ಏನಾಯ್ತು ಓವರ್ ಈಗ n into n minus 1 by 2 ಅಂತ ಬರಿಬೋದ್ರಿ this entire series. So now we have to rewrite the sum of first n minus 1 terms, that is n into n minus 1 divided by 2. So here r to the power n into n minus 1 whole divided by 2. So now we will take up the left hand side. LHS which is equals to P square. It is P square. Then which is equals to, what is P here? I will replace P, A raised to n into R to the power n into n minus 1 divided by 2. Then whole to the power 2. See here, P square, this is P, the whole square. Now this square applies to the first term as well as to the second term, which is equals to, what do we have now? A raised to 2n into A to the power 2 will be multiplied with this now. 2 get cancels, we get only n into n minus 1. So now overall this can be written as A to the power 2 into R to the power n minus 1 whole raised to n. ಈ ಥರ ಬರಿಬೋದೇನು ನೋಡ್ರಿ, ಇದೇ ಟರ್ಮ್ನೇ ಈ ಥರ ಬರ್ಕೊಂಡಿವಿ ನಾವು. ಹೌದ್ರಿ, A ಸ್ಕ್ವೇರ್ ಇಂಟು R raised to n minus 1 whole to the power n. ಇಲ್ಲಿ ಪವರ್ ಏನಾಗ್ತದೆ ರೀ, A B whole raised to m ಫಾರ್ಮ್ದಾಗ ಅದ. A raised to m ಇಂಟು B raised to m ಅಂದ್ರೆ ಇದು ಪವರ್ ಇದಕ್ಕೂ ಅಪ್ಲೈ ಆಗ್ತದೆ, ಆಮೇಲೆ ಸೆಕೆಂಡ್ ಟರ್ಮಿಗೂ ಅಪ್ಲೈ ಆಗ್ತದೆ. ಅಂದರೆ A power 2n ಇಂಟು R raised to n ಇಂಟು n minus 1 ಬರ್ತದೆ, ವಾಪಸ್ ಅದೇ ಟರ್ಮೇ ಬರ್ತದೆ. ಸೊ now A square can be written as A into A. Here A square can be written as A into R raised to n minus 1 to the power n. What is this A into R raised to n minus 1? A into R raised to n minus 1 is nothing but small b. Let us replace this by b, which is equals to, this is equals to A. I will be writing the first term as it is A into b whole to the power n. This is the required RHS. So this is our required RHS. So this implies the left hand side which is equals to the right hand side. So note down this, then we'll move on to the 24th problem. Well, the 24th question, it is show that the ratio of the sum of first n terms of a GP to the sum of terms from n plus 1th to 2nth term is 1 by r raised to n. So, he is talking about sum of the first n terms and then sum of the terms from n plus 1th to 2nth term. So, I will write a series here. I will write a geometric series A1 plus A2 plus A3 plus so on plus AN. So, this is the sum of first n terms of a GP. What will be the next term of AN? It is AN plus 1. So, now plus AN plus 1 plus what is the next term? It is AN plus 2 plus so on plus A2n. It is A2n. So, now this is going to be Sn. So, this will be Sn, that is the sum of first n terms of a geometric progression, and overall A1 to A2n is going to sum of first 2nth terms. Now see here what we have to find. We need to find the ratio of sum of the first n terms, that is Sn divided by to the sum of terms from n plus 1th to 2nth term. This we need to identify now. That means you need n plus 1th to 2nth term. We have to take the sum of this now. So, how do you take the sum of terms from n plus 1th to 2nth term? What I do is, I need this sum. So, I take the overall sum from A1 to A2n, that is going to be S2n. So, in the overall, if you subtract this part, we are going to have the sum of the last part, that is n plus 1th to 2nth term. So, overall, this portion can be written as S2n, I am taking the overall, S2n minus this portion, so that we get the sum of this, S2n minus Sn, S2n minus Sn, which is equals to, what is Sn here? Sn is going to be A into 1 minus r raised to n divided by 1 minus r, then whole divided by, this is the numerator, Sn I have written, divided by, I have to write S2n minus Sn. So, here A 1 minus r to the power 2n now, 2n divided by 1 minus r, and then minus Sn I have to write, that is A into 1 minus r to the power n divided by 1 minus r. Observe the denominator now. So, here you have the same denominator, that means the LCM is going to be 1 minus r in case of the denominator. This is equals to, so I will write the numerator as it is, A into 1 minus r raised to n divided by 1 minus r as it is, then whole divided by, take up the LCM now, A into 1 minus r raised to 2n, 1 minus r raised to 2n, then minus A into 1 minus r raised to n, then whole divided by, the LCM is going to be 1 minus r. So, 1 minus r and 1 minus r get cancels now. These two get cancels. Let us simplify this further. This is equals to, write the numerator as it is, A into 1 minus r raised to n divided by 1 minus r, then whole divided by. So, now in these two terms we can take A common. I will be taking A common, then inside the bracket write the remaining terms, 1 minus r raised to 2n as it is, 1 minus r raised to 2n as it is, then I have taken A outside, there is a minus sign, multiply minus with these two terms, you get minus 1 and then plus r raised to n, and then here A and A get cancels, and then plus 1 minus 1, that also get cancels, write the remaining term, this is equals to 1 minus r raised to n, 1 minus r raised to n divided by 1 minus r, divided by 1 minus r, and then write the remaining term here. So what do we have? R raised to n minus r raised to 2n divided by, whole divided by r raised to n minus r raised to 2n. Sorry, 1 minus r got cancelled out. So now I'll be writing the remaining term 1 minus r to the power n, then divided by r raised to n minus r raised to 2n, r raised to n minus r raised to 2n. So in the denominator we can take r raised to n common. So here 1 minus r to the power n as it is, then denominator we can take r raised to n common. I get 1 minus r raised to n. R raised to n into r raised to n will be r raised to 2n. So now 1 minus r raised to n and 1 minus r raised to n get cancelled. So write the remaining term, that is going to be 1 divided by r to the power n. So this is the required answer for the 24th problem.